Good morning, everyone. Today we'll have a small discussion on the topic circular measures. Okay, so in circular measures, we need to remember two main topics, which are nothing but the length of an arc and area of a sector. Length of an arc and area of a sector. So let's consider a sector with a radius r unit and the angle subtended by the arc at the center is theta radian. Remember, circular measure is also known as radian measure. Okay, then length of an arc can be calculated using the formula r theta. Length of an arc is equal to r theta and area of the sector A is equal to half r squared theta. So these are the two formulae we need to remember when we are discussing about length of an arc and area of sector using circular measure or radian measure. At that same time, remember the concept of length of an arc and area of sector using degrees as theta by 360 times 2 pi r as length of an arc and area of a sector is theta by 360 times pi r squared. This one we use in the system when we use degrees, that means in hexadecimal system. But when we use a radian measure or circular measures, we use the length of an arc as r theta and area of a sector is half r squared theta. So now let's discuss a few past paper questions. Our first question is from winter 2018 paper 1-2. As per the question, when you read the question, you can understand ABC is an isosceles triangle. Before that, you have to identify two sectors. So the first thing what you need to do is learn the picture, understand the picture. So when you look at this picture, you can find AXC is a sector with radius 12 centimeter and BYC is another sector with a radius of 8 centimeter, and in both the sectors we do not know the angles. So that may be one of our tasks to find out. That means find angle BYC and angle BAC, because when you take this sector, AXC, the radius is 12 centimeter and this is our angle theta, and we do not know what is that angle. So our task is to find out that angle. That is one of our angles. Without knowing that angle, we cannot find out the length of arc XC or area of the sector AXC. Similarly, when you take sector BYC, it has radius 8 centimeter, and without knowing the angle theta, angle YBC or CBY, without knowing the angle CBY, we cannot do any further calculations. So anyways, according to that, our first question is to find angle CBY, and we have to show that angle CBY is equal to 1.445 radian. We have to show that angle CBY is equal to 1.445 radian. What can we do for that? To find angle CBY. For that, if we are able to find this angle, which angle? Angle ABC. If we can find out angle ABC, then you can identify these two are linear pairs. They add up to pi radian. So you can find angle CBY as pi minus this angle. Now our task is to how to find out this angle. Now here I have drawn that figure separately. The figure, we could find ABC is a triangle in which the sides are 8 centimeter, 8 centimeter and 12 centimeter, and we need to find an angle. So when you look at a question like this, you have to remember a property or a rule from trigonometry known as cosine rule. So as per cosine rule, we can understand 12 squared is equal to 8 squared plus 8 squared minus 2 times 8 of cos angle ABC, or cos angle ABC can be found by taking all other terms to the next side. Transpose all the terms to the next side. We get 12 squared minus 8 squared minus 8 squared all divided by minus 2 times 8 as 128. Or angle ABC is equal to cos inverse of this. Is 12 squared minus 8 squared minus 8 squared all divided by minus 128, which is equal to approximately 1.696. So that we can find out angle CBY, because once we get this angle as 1.696, we can find angle CBY by subtracting 1.696 from pi. So angle CBY is equal to pi minus 1.696 radian, which is equal to 1.445 radian as a result. Question B is to find the perimeter of the shaded region. It's very clear that perimeter of the shaded region is the length xy plus arc yc plus length of the arc xc. So the perimeter is the line segment xy plus the length of the arc yc plus arc length xc. So these three measurements to be found out now. Okay, so now first let's find the line segment xy. So when we think about the length AB is 8 centimeter. And can you say what is BY? the length of BY, this length, that will be same as length BC, that's also 8 centimeter. So BY is also 8 centimeter. So what is the length AY? So AY is nothing but 16 centimeter, and you know that AX is 12 centimeter. It's given in the question because AC is 12 centimeter, which is same as AX, because both are the radii of the sector AXC. So now we can find the length XY is equal to AY minus AX. AY minus AX, which is equal to 16 centimeter minus 12 centimeter, that is 4 centimeter. So we got the length of XY as 4 centimeter. Now our next task is to find the arc length YC. So to find the arc length YC, let us take the sector BYC. Let's take the sector BYC. So in sector BYC, the radius is 8 centimeter and the angle theta is 1.445 radian, that we found in the first part of the question. So the radius is 8 centimeter and theta is 1.445 radian, so that the arc length YC, arc length YC is equal to r theta, which is equal to 8 times 1.445, which is equal to 11.56 centimeter. So we are getting the length of the arc YC as 11.56 centimeter. Now our task is to find the arc length XC. So for XC, we need to take the sector AXC. Take the sector AXC. But when we consider the sector AXC, angle A, that means theta, is missing. So we need to calculate theta. But from this figure, from this sector, we cannot calculate theta. For that, let's take this triangle ABC. So when you take triangle ABC, it's given that AB is 8 centimeter and BC is also 8 centimeter. That means AB and BC are of equal length. That means triangle ABC is an isosceles triangle. We know that in an isosceles triangle, the base angles, means angles opposite to equal sides, are equal. That means these two angles are of equal length. So if we consider this angle as x, this angle also will be measured as x. And now make use of angle sum property. We get 2x plus 1.696 is equal to pi, or x is equal to pi minus 1.696 divided by 2, which is equal to 0.723 radian. That means angle A is nothing but 0.723 radian, because x is assumed as angle BAC as well as angle BCA. Okay, So now let's find the arc length xc. So arc length xc is equal to r theta, which is equal to 12 centimeter into theta is 0.723 radian, which is equal to 8.67 centimeter. So that we get the perimeter of the shaded region is 4 centimeter plus 11.56 centimeter plus 8.67 centimeter, which is equal to 24.23 centimeter as answer. Another question. The diagram shows a circle with center O and radius r centimeter. The points A and B lie on the circle, and AT is a tangent to the circle. Angle AOB is equal to theta radians and OBT is a straight line. So here they have given AT is a tangent to the circle and OA is the radius. So make sure angle A is 90 degree, because a tangent is perpendicular to the radius through the point of contact. And angle AOT, that means angle AOB, is theta radian and OBT is a straight line. Yes, these are the things given in the question. So first part of the question is express the area of the shaded region in terms of r and theta. We have to find out the area of the shaded region in terms of r and theta. So what's our plan to find the area of this shaded region? It's very simple. Just pause the video and think what's your plan and do it, and then continue to watch. Okay, so the area of the shaded region, area of this shaded region is area of triangle OAT minus area of sector AOB. Think, is it correct? So area of shaded region is area of triangle AOT minus area of sector AOB. Yes. Okay. Now to find the area of triangle OAT, area of triangle OAT, we required the base and height. We need the base and height. So how do we calculate the base and height? Here the base can be considered as AT and height is OA, which is r centimeter. So height is mentioned as r centimeter. Our task is to find out AT. For that, let's use the term tangent. We know that tan theta is opposite side divided by adjacent side. So tan theta is equal to AT by r, or AT is equal to r tan theta by using cross multiplication. So that we get area of triangle, area of triangle OAT as half into base into height. That is, half into base is r tan theta into height is still r. So we get it as half r squared tan theta. As we have two r's, we get half r squared tan theta as the area of triangle. Now you have to find the area of sector. It's very simple. Area of sector is nothing but half r squared theta. That is same as here also, because theta is same as theta and the radius is r. Therefore, area of shaded region is equal to area of triangle, that is half r squared tan theta minus area of sector, which is half r squared theta. And still you can simplify by taking half r squared as common. We get the result as half r squared of tan theta minus theta. Okay, so this is the first part of this question. And the second part of the question is, in the case where r is equal to 3 and theta is equal to 1.2, find the perimeter of the shaded region. So in the question, if r is 3 and theta is 1.2, if r is 3 and theta is 1.2 radian, then find the perimeter of the shaded region. So what is the perimeter of the shaded region here? It's nothing but length AT plus length BT plus the arc length AB. So we need the length AT plus length BT plus arc length AB. Yes, so let's go for the length AT. Look, in the previous question, we found out the first part of the question, we found out AT, the value of AT as r tan theta. So when you replace r and theta here, we get 3 times tan 1.2, which is equal to 7.72 centimeter as the length of AT. So let me write the length of AT here. So AT is 7.72 centimeter. Okay, now our task is to find the next length. Which is the next length? The length BT. We have to find the length BT. This length we have to find out. The length BT. Okay, so how can we find out length BT? So to find out length BT, let us take this complete triangle. ATO. Let's take the triangle. A T O. So in this triangle already we found AT as 7.72 and this angle is given as 1.2 radian, and if we know the length of OT, from OT, if we subtract the radius OB from total OT, if we subtract the radius OB, we get the length of BT. Yes. So let's find the length OT, and already we know that the triangle is a right triangle, so we can use the trigonometrical ratios directly as sine 1.2. So we get sine 1.2 radian is equal to opposite side divided by hypotenuse, which is OT. So we get OT as 7.72 divided by sine 1.2, which is equal to 8.28 centimeter as length of OT. So the length of OT is 8.28 centimeter, and you know this radius is 3 centimeter. So from the total length, if you delete the radius 3 centimeter, we get the length of BT. Therefore, the length of BT is equal to the total length OT minus radius. That's equal to 8.28 minus radius is already given as 3 centimeter. So we get it as 5.28 centimeter as BT. So we got BT also. So the length of BT is 5.28 centimeter. Now only one measurement is left, which is the arc length. So to find the arc length, remember the formula r theta. So use the formula r theta. That is to find this arc length. Use the formula r theta, where r is 3 centimeter and theta is 1.2 centimeter. So the arc length is AB is r theta, which is equal to 3 times 1.2, which is equal to 3.6 centimeter. Therefore, the perimeter is AT, the length AT plus the length BT plus the arc length AB. That's equal to 7.72 centimeter plus 5.28 centimeter plus 3.6 centimeter, which is equal to 16.6 centimeter as the perimeter. Now this is a question from October-November 2018 paper 1-1. The diagram shows a triangle OAB in which angle ABO is a right angle and angle AOB is equal to 1 by 5 pi radians, and the length AB, side AB, is 5 centimeter. The arc BC is a part of a circle with center A and meets OA at C. The arc CD is a part of a circle with center O and meets OB at D. Find the area of the shaded region. Okay, so this is also an interesting question. So in this we have to find the area of shaded region. So how do you find the area of shaded region? So from this total area, that means from the total area of triangle, this is the total area of triangle. If we delete the area of this sector and the area of the sector ABC, we get the area of shaded region. Is it? So area of shaded region is area of triangle ABO minus, delete from triangle ABO, what we have to delete? Area of sector OCD and area of sector ABC. This is a plan we are doing. Okay, this is a plan, just 1 minute plan we are doing. Okay, now to find the area of triangle ABO or area of sector OCD or area of sector ABC, we require a few measurements. Like if you want to find the area of triangle ABO, we want the base and height. Already height is mentioned as 5 centimeter, so we need to calculate OB, the base. And as it is a right triangle, we can use the trigonometrical ratios directly. Like if you use tangent, we can find the length OB, so that we can find the area of triangle ABO. So that is the first concept we have to use. Okay, now when we look at the next sector OCD, when we look at sector OCD, in this sector OCD, the theta is given as 1 by 5 pi radian, but we want radius because area of sector is half r squared theta. So how do you find r? For that also make a plan. It's nothing but we know that the length AC is also 5 centimeter because AB is 5 centimeter, AC is the next radius. And if we know the length OA, if we know the length OA, from OA, if you delete the length AC, that means 5 centimeter, we get the length of OC, which is the radius of the sector. Okay, and of course in this next sector, in sector ABC also, one thing is missing, which is nothing but angle A. Angle of the sector is missing, and it is so easy to find out. Using angle sum property we can find that angle. Okay, so pause the video and start doing the work. Okay, now when we think about the total area of triangle ABO, area of triangle ABO, AB is given as 5 centimeter and angle O is given as 1 by 5 pi radian. So let's find OB first. We can find OB as OB is the base and OB is the adjacent side and opposite side is also given. So let's find OB using tangent. So tan 1 by 5 pi or pi by 5. 1 by 5 pi is same as pi by 5 is equal to opposite side by adjacent side, or OB is equal to 5 divided by tan pi over 5. That's equal to, what is the answer? 6.882 centimeter. So OB is 6.882 centimeter. OB is 6.882 centimeter. Therefore, area of triangle ABO is equal to half BH, that is half into base is OB, that is 6.882 into height is 5 centimeter. So we get the result as 17.205 centimeter square. As area of triangle. Now we need area of sector OCD. We want area of sector OCD. Okay, but even if you want to find the area of sector OCD, we need the length OC. But to find the length OC, we must know the length OA, because from OA, if you delete AC, which is 5 centimeter, we get the length OC. So how do you find the length OA? How do we find length OA? Yeah, we can use trigonometrical ratio sine, like sine pi by 5 radian is equal to opposite side divided by hypotenuse. So we get the hypotenuse OA is equal to 5 divided by sine pi by 5. That is the length OA, which is equal to 8.506. Therefore, the length OC is equal to 8.506 minus AC, which is 5. So we get it as 3.506 centimeter as the radius of the sector OCD. So when we consider sector OCD, the radius is 3.506 and the angle is 1 by 5 pi. So area of sector OCD is equal to half r squared theta, which is equal to half into 3.506 squared times pi by 5, which is equal to What is the answer for this? When you multiply 3.87 centimeters square. Okay, now we need one more area, which is the area of sector ABC. But to find the area of sector ABC, radius is given, angle is missing. So we can find this angle easily using angle sum property. The total pi radian, delete 1 by 5 pi and pi by 2. So that is pi minus pi by 5 minus pi by 2. What we get? The angle. What is the angle? Yes, 3 pi by 10. So angle is 3 pi by 10. Therefore, area of sector ABC is half r squared theta. That's equal to half phi squared into 3 pi by 10, which is equal to 11.780 centimeter square. So now we got all our required areas. Hence, we can find out the area of the shaded region. How do you find the area of the shaded region? It means total area. That means area of triangle minus area of the sector minus area of the sector. So let's find that. So area of shaded region is equal to total area. Total area is, how much is total area? We found out total area. That means area of triangle. Yes, it is 17.205. 17.205 minus area of a sector. What is area of a sector? Yes, it is 3.87. So what is it? Where is it? Where? 3.87 minus area of second sector. Area of second sector is 11.780. So subtract these areas, we get the answer as 1.56 centimeter square, which is the area of the shaded region.